Hello my dear students, today we will be discussing about the important topic of your previous chapter, that is the machine. So one of the simple machine we are going to study about are the levers. So what is a lever now? Lever is a very simple. So lever, it can be either a straight. So lever can be a straight, bend or straight or bend. Okay, bar. One more important term is bend and as well as rigid also. Okay, so while defining the lever, you must keep in mind these three things. It can either be a straight, it can be a bend, but whether it is straight or bend, it must be a rigid bar. Okay, so it must be a rigid bar that is capable of rotating about a fixed point. So it is capable of rotating about a fixed point, and that fixed point is known as a fulcrum. Okay, so what is a fulcrum? So fulcrum is a point where a rigid bar is capable of rotating. So we'll be discussing about the three kinds of lever, its mechanical advantage and the velocity ratio. So let us see what are the three different kinds of lever. So we have the three different levers we have the class 1 lever, class 2 lever and the class 3 lever. So in examination you may be asked to draw these three kinds of lever as well. So it's very simple. So you simply draw a bar, class 1 lever, class 2 and then class 3. Okay, so this is class 1. This one is class 2 lever and this one is a class 3 lever. So how to differentiate between these three levers? You remember the word pre. Okay, so F, L, E and start writing from here. So at the central part it is F, L and E. Okay, so if the fulcrum is in the center, so the load can be either here and the effort on the other side, or the load here and the effort that side is the same. Okay, so then here if L is here, so the fulcrum I can draw it here F and the effort here E. Okay, and the effort is here, so that's why I can keep a fulcrum on one of the side F and the load on the other side. So this is how we can draw the three classes of lever, simply remembering the word F, L and E. So now coming to find the mechanical advantage of this. Okay, so F, L and E, it's very simple to find which of the lever has a mechanical advantage greater than 1, which has equal to 1 and which has a lesser than 1. So to know that, what can we do? We can use the principle of machine. Okay, so the principle of machine, we have that the work input is equals to the work output. So here what can I do? The work input is equals to the force, it is the effort into D of, or I'll write here E of A, that is the effort arm, equals to L into L of A. Okay, so that is the load arm. So this I can write. So what is the definition of mechanical advantage? The mechanical advantage is the ratio of load to the effort. So I'll take the E that side. So I'll make L divided by E will be equals to, bringing this one there, EA divided by LA. Okay, or simply load by effort is the mechanical advantage. So the mechanical advantage is equals to the effort arm divided by the load arm. Okay, so the mechanical advantage of the lever system is the ratio of the effort arm to the load arm. So what is the effort arm and the load arm? Remember, the effort arm is the distance of the effort from the fulcrum and the load arm is the distance of the load from the fulcrum. So let us discuss about the mechanical advantage of the three types of lever in details. So for a class 1 lever. Okay, so first class 1 lever, we have the mechanical advantage is equals to EA divided by LA. So now come to the class 1 lever now here. So for the first case, so what is the EA? EA is the distance from fulcrum to the effort. So this is EA, and from load to the fulcrum it is LA. So if the case is the fulcrum at the central part of the load and the effort, so the load arm and the effort arm are going to be equal. So in that case, the mechanical advantage of class 1 lever can be 1. So when is the class 1, the mechanical advantage of class 1 lever equal to 1? When the fulcrum is at the center of the load and the effort. Now come to the next case. The next case being the effort arm being longer now. The effort arm is longer here. Okay, so in that case, so here I have EA. So in that case, the ratio, coming to the ratio, the numerator being greater than the denominator. Okay, so when EA is greater than LA, what happens? The mechanical advantage will also be greater than 1. Okay, is that clear? Now the third one, the third case being, now when the load arm is longer. Okay, so the load arm being longer than the effort arm. So in that case, now, so this is the first case, this one is the second one, and the third one is when the EA is smaller than the LA. When the denominator is bigger than the numerator, in that case, the mechanical advantage will be less than 1. Okay. So we see that for a class 1 lever, the mechanical advantage can be equal to 1 also, it can be greater than 1 also, and it can be lesser than 1. So if any system has a mechanical advantage equal to 1, we can use it as a direction changer. That means using it we can obtain the change in direction. If something has a mechanical advantage greater than 1, it's a force multiplier. And if something has a mechanical advantage less than 1, it is a speed gainer. So we see that the class 1 lever can be used as a direction changer, okay, where the mechanical advantage is equal to 1. It can be used as a force multiplier, and it can be used also as a speed gainer. Now coming to the class 2 lever, okay, so the mechanical advantage, again I'll write here EA divided by the load arm. So now when we see here the class 2 lever, so I'll mark, so from here to here it is the load and fulcrum, so this is the LA, and from here to here it is the EA. So it is clear that the effort arm is always greater than the load arm. So the effort arm is always greater than the load arm. So in that case, the mechanical advantage will always be greater than 1. So we can see that the class 2 lever, they are always a force multiplier, because the mechanical advantage is greater than 1. And why is so? Why is it so? It is so because in case of a second class lever, the effort arm is always greater than the load arm. Now coming to the class 3 lever, okay, so the mechanical advantage is equals to the effort arm divided by the load arm. So in this case, now let us come back to the class 3 lever. So where is the effort arm? So from here to here it is the effort arm EA, and from here to here it is the LA. Okay, so we see that the load arm is always greater than the effort arm. Okay, so in this, so here we have the load arm is always greater than the effort arm. So that is, the denominator of a fraction is always greater than the numerator. So in that case, the mechanical advantage will always be lesser than 1. Okay, so that means the class 3 lever can be used as a speed gainer. So this was about the mechanical advantage of a 3 types of lever, and this is very important from your examination point of view. So you will be asked to draw the 3 class of lever and also come in on its mechanical advantage. So it's very easy for you to remember this, that the class 1 lever, it can have a mechanical advantage equal to 1, lesser than 1 and greater than 1. That means it can be used as a direction changer, the force multiplier and a speed gainer. Now the class 2 lever, the mechanical advantage is always greater than 1. That means the class 2 lever always acts as a force multiplier. And coming to the third class of the lever, so in that case, the mechanical advantage seemed always lesser than 1. That means the class 3 lever can always be used as a speed gainer. So what will you do? You will learn the derivations of the mechanical advantage for a lever, and also the discussion on the mechanical advantage of all the 3 types of lever. And also it's very mandatory for you to remember the example of each classes of lever. Like here we can take the example of this one is a plier also, okay, or a seesaw. Here the force multiplier, the nut crackers, the speed gainer, the what is that called? The speed gainer. So the example of a speed gainer, you can take it as a scissor also. Okay, so apart from that, you may remember at least 2-3 examples of each classes of lever, which will be very helpful for you to write it down during the examination where the questions are being asked. So in the next class, we will be discussing about the second type of simple machine, that is the pulley system. Thank you.